So we're going to look at solving logarithmic equations. We're going to have multiple steps. We've talked about single steps. We're going to do some multiple step stuff. You'll need your calculator handy. Some of the math on here is going to be a little high, so let's just jump right into it. We've got about 6 examples we'll take a look at here. On the first one here, our log bases are already the same. It's very important that you look and make sure there's nothing else attached. Like if I had a +5 or +7 or whatever at the end of this, I cannot do the step that I'm about to do. But all that I see is the logs, and everything inside of it is attached to the log. These are actually real easy first steps. So the way I get rid of a log base 6 is with a base 6. And since both sides, that's all they have, all I've got to do is turn those values into the exponent to the 6. And since this is now an inverse function, log base 6 and 6 are going to cancel one another. So since those have canceled one another, my result is now just a linear function. I'm going to drop those exponents down. And now we're back into just that algebra 1 solving for y. So I'm going to move the 3 in to join the 5 in. And on the same line, I'm going to move the 8 over to join the 10. So we end up with a -2n equal to 18. And when we divide by -2, we get a result of n equal to -9. You could go back and plug these in if you wanted to see those. You could graph these and see where they cross the x-axis, or cross one another, excuse me, or you could gather everything to one side and see where it crosses the x-axis. So this is how we solve when we have the common log, not common log, excuse me, a shared log. Remember, common log refers to the base 10. So we will put that in either parenthesis. So this one, we have the same thing. The reason why we're doing another one of these is because this one is a quadratic. We should know how to solve quadratics, but it's been a little while, so we'll go ahead and take a look at what we've got going here. So since we have both log base 18, we can go and drop a base 18 in order to cancel those. Remember, this only works when all we have is the logs. You can't have anything else. And the n squared plus 20 and the -11n plus 2, those were in the parentheses, so they were grouped with those. That's why we were able to do that. So now this is a quadratic equation, so we can't solve for n because there's more than one n. So anytime we want to solve for a quadratic, what we're going to do is gather everything to one side. So I'm going to move the 11n over to join the n squared plus 20. So I would have n squared plus 11n, excuse me. And then subtract the 2 from the 20, which would give me positive 18. Remember, with quadratics, we got to gather everything to one side, and at this point, we can do a number of things. We can solve by factoring. We could use the quadratic formula. You could complete the square even. I would not suggest completing the square, but we can do any of these things. Now, I recognize the factors of 18 that can become 11 pretty easy, but before we go into that, one other thing I want to talk about is understanding that quadratics have the potential of having 2 solutions. But remember, the way we factor this is we find all the factors of 18. 18 is 1 times 18, 2 times 9, 3 times 6, 4, 5, and that would be it. Remember, these factors need to add up to become 11, and 2 and 9 do. The 9 and the 2, it does not matter which one you put them in. And then now we set each of these parentheses equal to 0. And as promised, we have two solutions. We subtract the 2 away. Go ahead and do this on the other side as well. Subtract the 9 away. And we're down to our two solutions, which is n equal to -2 and n equal to -9. So that's a quadratic inside of a logarithm. So now we're going to look at some that don't have that common or shared log on either side. You can see what we're dealing with here is actually the natural log. There's our natural log right there. Anytime you're doing this, you need to just make sure that you pile everything off of the log first. Isolate the log and then perform the log function. See, like on this one, we can't come in here and just drop an e, because if I dropped an e in here, I'd have to drop on e on everything that has a plus sign, and what I'm actually doing is making a very big mess of this problem. So we're going to isolate the logarithm, or in this case it's the natural log. So we are going to first move anything that is not in a parentheses, adding or subtracting needs to be moved first. So I'm going to add 6 to this side. When I do that, now I have 9 natural log of p equals 0. That is not a problem. That does not automatically mean that it's a special case or one of those properties we talked about yesterday, but we should have our antenna up, kind of assuming something like that may happen. So we now divide by 9. So the 9's do cancel. Any number divided by itself is 1. So this becomes natural log of p equals 0. Now let's just say you forgot those logarithm properties that we discussed yesterday. You can still use the operation, which is the inverse to natural log, which is the natural base e. So I go in here and I would have e and natural log canceling one another. And like I just said, anything to a 0 power is 1, including e. And if you were to put that in your calculator, it's also going to give you a 1 as well. So we would have p equal to 1. I'm going to kind of step up on difficulty as we move through these questions, but the main thing is isolating the log first. Now, this log is attached to a couple of things. Let's highlight that and discuss that real quick. This log base 8 is attached to the 2a. That is its argument. And since they're connected by multiplication, I cannot get to that until I get rid of the logarithm. And I cannot get to the logarithm until I remove the two things that are on its side, the 6 and the -9. So adding or subtracting needs to take place first. Make sure that as you work through these that you are recognizing the math that should actually be happening here. Remember, the 9 is multiplying. Don't try to add this 9 over. And by the way, if you ever do the same function twice in a row, like subtracting a 6 and then adding a 9, if you did that from the same side, you should have been able to combine like terms. But these do not combine because the 9 is attached to something. So now I still don't have that log base 8 by itself, so I have to divide by -9. Told you the other day, anytime you have a 1, you need to pay attention for special cases. That doesn't mean that this one is, but just keep an eye on it. So I have log base 8 on 2a equals +1. We can't get to the 2a because it's the argument, but we have done this. We have isolated the log base 8. So all I need to do is get rid of it is take a base 8. What I do to one side, I have to do to the other. So log base 8 cancels base 8. And the 2a drops. And this is 8 to the 1 power. Well, 8 to the 1 power, anything to the 1 power is itself. So we have that. 2a equals 8. We divide by 2, and our a value equals 4. Now, I've picked kind of kind questions. If you've noticed on mine, a lot of these have become integers. All of them have become integers. But when we're dealing with logarithm, there's a very good chance that you're going to get an irrational number, so just be prepared for that. And when you get it, don't be surprised. All right, just 2 more examples. But like I said, we're going to kind of amp up the difficulty here. So again, if you need to highlight it, highlight it. So there's our log, and it's attached to this. So we're going to isolate this. It's always got to have an argument. And this one you need to recognize as well. This is a log base that's blank. We don't have anything down here in the log base. Well, we've got to recall that if it's not anything there, it's an understood 10. So we will be dealing with a log base 10 here. But that, not yet. First thing we want to do is remove everything. Think about the math that is happening. A lot of people look at this 7 and say, well, that's a minus 7. No, that 7 is not multiplying times anything, or excuse me, adding to anything or subtracting in this case. It is multiplying. So when we get to that, we'll have to do the inverse. The 5, on the other hand, is actually adding. So we do that, and we get to 14 equals all this other stuff. Whoops. Don't need a parentheses there. Multiplication is implied. So this would be common log 1 minus 9n. We divide by negative 7. Just a reminder, we shouldn't see this in logarithms, but remember, if you're dealing with inequalities, when you divide by a negative, you would have to flip that inequality. Not our concern on this one because it's not an inequality. Just wanted to keep your mind where that goes. So we have 14 divided by negative 7, which is negative 2. Now be careful of this. We said beware of negative numbers, but in this case it's not a problem because it's now going to need a base 10 because remember this is common log, which means the base is an understood 10, so it's 10 to the negative. Once I do that, I get to drop my log and I get 1 minus n, 9n, excuse me. Now let's go to the side real quick here. I don't care how you do this. This one you can put in your calculator, but I want you to understand that anytime you have a negative exponent, you're able to make the reciprocal and drop the negative sign. 10 becomes 1 over 10, and we can drop the negative sign. This is actually easy to do. We can do it in our head. It's 1 squared over 10 squared. Well, 1 squared is 1, 10 squared is 100. So what we end up with is 1 over 100. So now we need to isolate the n value because we've gotten rid of the log. Now I'm going to show you a little trick here. I'm going to subtract 1. Why not just subtract the fraction that we're used to? 100 over 100. So we end up with negative 9n and 1 minus 100 is negative 99 over 100. And the last thing we need to do is divide by negative 9. Remember, dividing by negative 9 is the same thing as multiplying times the reciprocal, 1/9. Don't confuse what I'm about to say with cross multiplying. Cross multiplying is uncommon. We do have a cross cancel here. You could actually do the math, and it ends up being negative 99 over 900. But if you can recognize, oh, well, these share a factor, well, you can cross cancel these right here, and this becomes 11. And I just noticed a mistake an omission I had. Remember, this was negative 9, so I need to divide by negative, so the sign is going to change. So this would become not negative 11, but 11 over 100. And this is one of those where I talked about if you fall in love with the calculator, a lot of times what you're going to run into is numbers that don't really jive well. They have sometimes it's irrational, but this is just a really weird decimal here. Move the decimal place over twice. All right, example. Again, isolate first. There's going to be two isolations because we're going to have to isolate our log base 3, which is connected to this. So we're going to isolate all of this stuff. So we got to start removing stuff that's not our log. So the 1 has got to go first. So I add 1 to both sides. Now I have 8 log base 3 on 10n minus 7 equals 8. Hopefully we see the next part to getting it by itself would be to divide by 8. So I divide by 8, the 8's cancel. Now I'm stuck with log base 3. 10n minus 7 equals 1. Now think about that real quick. How do I get rid of a log base 3? Well, hopefully you said log base 3 gets eliminated with a base 3. 3 to the 1 power, of course, is 3. So we end up with 10n minus 7 equals 3. And at this point, it's just solving a linear equation. So the 7 goes over to join the 3. We get 10n equals 10. Divide by 10. Therefore, 1. N is 1. So remember, isolate the logarithm, eliminate the logarithm, and then solve for your variable.